We're going to talk about voltage. What the hell is voltage? Well, the other day we talked a little bit about electricity, and before that we've been talking about mass and energy, especially another form of mass. Mass is another form of energy, right? And there were some issues that were brought up, and so we need to address those before, as an introduction to the subject matter of today. Okay, okay, so one fellow says, this is what most people use the term physics for. Uh-huh. Alpha Phoenix gives a link, says Alpha Phoenix did what most people call physics to verify Derek Muller's claim, because I dealt with Derek Muller's notion of what electricity is. Okay, flow of particles. He says not really. It's in situ. Something happens there. The electrons move back and forth. You know, from atom to atom. They don't go all the way to the terminal. Okay, what do you call it? Technology, mathematics. Okay. Yeah, we got a problem because these people don't understand what physics is about. They don't understand what science is about. That's the issue. And when you go to this Alpha Phoenix guy, you find that. What do you find? You find the same exact thing as what Derek Muller had. In other words, he hasn't changed anything. He hasn't said anything different than Derek Muller. And so he says, the fact that he challenged Derek Muller. No, they said the same thing. They used the same electricity. They said that there's an electron bead, okay, that moves from one atom to the next, to the neighbor, okay, because this is what they learned at the monastery. Okay, they learned that electricity is the flow of electrons. Whether they flow all the way around, whether they flow only to the next atom, then come back like in alternate current, it's the flow of electron beads from one atom to another, the conduction band, right? That's what's known as electricity in just about everywhere. The Electric Universe believes in that. The John Chappell Society, people who believe in particles and ether and stuff like that. You have the quantum mechanics, string theorists, general relativity. They all, even the classical people who believe in classical mechanics, everybody essentially believes in that that the electricity is the flow of electron beads, and in order to come up with that notion, they have to use the quantum atom. And the quantum atom is the planetary atom. So that's why they have this little bee that's going around, right? The nucleus. There's a bowling ball in the center and an electron bead going around, this grain of sand that goes around. The only thing they have to do is draw their model of the atom. We can go with the hydrogen atom. We don't have to have iron or copper or anything more complicated. Just draw for me the hydrogen atom, and then explain why, okay, the electron bead doesn't fall to the center where the nucleus is, or why it doesn't spontaneously fly away. If you cannot explain that, you do not have an atom, and your explanation of electricity, the flow of electron beads from atom to atom, is bunk. Okay? And so what Derek Muller did is the same thing as Alpha Phoenix did, is the same thing that everybody else does out there. And they're using the wrong atom. They're using an atom they cannot justify. It's an irrational atom because they don't know why that little bead goes around, any more than anyone can explain to you why Pluto goes around the sun. Okay? What's keeping Pluto bound to the sun? That's what you got to explain. Why doesn't Pluto fly away from the solar system spontaneously? And if you say that there is nothing connecting, physically connecting Pluto with the sun, simply because you can't see it or touch it, then you put a spirit in that same region. You're doing your theory with black magic. You're seeing nothing is in contact between Pluto and the sun, but Pluto doesn't fly away. That's what you're saying. And what you're saying, essentially, whatever theory you have, I don't care, because whatever theory you have, you're using black magic. You're saying it's done without a mediator, without a physical object mediating Pluto with the sun. That's what you're saying. Okay, and that is irrational science. Okay, science, big word there. Just irrational. That's an irrational theory. You have to have a rational theory. In order to have a rational theory, you need a mechanism. In order to have a mechanism, you have to mediate it, you have to simulate it with a physical object. The fact that you can't see or touch it does not make it does not say that there's no object there. There is an object there. We just can't see or touch it, because an object is that which has shape, not that which you can see or touch. Okay, so how do we answer this gentleman here? Well, we answer this way. Don't just follow the herd of buffalo to the edge of the cliff. I mean, the guy says, this is what most people right, believe is physics. Okay, I don't know about most people. We don't care about most people. You don't follow the herd of buffalo to the edge of the cliff. Try to get a brain of your own. Don't use borrowed brains, especially that of the the scarecrow there. When he went to Oz, he left his old brain there, and he got a new one, I guess, right? That's what the Wiz gave him. So you don't want to use his brain now. Maybe they sell you his brain at a discount or something. Don't take it. Okay. You'll have a tough time though. Independently thinking brains are scarce. Okay. So you'll have to shop around. Meanwhile, remember that science is not equal to democracy, authority, or tradition. Okay, so this notion that this fellow has that, oh, the majority of people believe that physics is blah, 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 blah. We don't care what the majority of people think. Okay, we don't go by the majority. This is not democracy. We all vote. It doesn't work that way. Not in science. In science, you got to rationalize it. You got to defend your definition. And so he didn't put a definition for physics, but he suggests that the notion of physics is what this guy did, which is criticize Derek Muller. First of all, criticism is not science. Explanation is science. That's the first one. And the second one is that this guy proposed the same thing as Derek Muller, which is the planetary model, and that electricity consists of the flow of beads, electron beads. Okay, so this fellow has said nothing new. Okay, here we have something new, something different, but this fellow, he's got the same thing as everybody else. Okay, another fellow talking about being parrots here, right? Just mimicking what the authorities and the superiors told him. Says electrical energy is one of about 25 types of energy. Okay, a form of energy that results from the flow of what? Charged particles. What are those particles? The electron beads, right? And their charge means they have 1.6 times 10 to the minus 19 coulombs each, right? A quantity it carries, the electron carries with it. Energy is defined as a catch-all what? Capacity. Capacity to do work. So what is energy? It's capacity, whatever that is. Okay. There's no physical standalone object called capacity, as far as I know. Okay. But if you find one, please draw it, bring it to the conference. Okay. A battery is a form of stored electrical potential energy. We're going to be looking at the battery today, so it's a good introduction to the subject. It has potential energy, potential capacity. What does that mean? Potential capacity. Okay. Charge is charged, like in charged particles, is a property of matter. Okay. So there is no physical object called charge. You can't say you're going to move the charge, right? Because he's saying it's a property. It's like saying I'm going to move the color red of the sweater. Sweater is red, or it's big. You can't move big. You can't move red. You got to move the sweater, right? So we have to distinguish the property of the sweater from the sweater. Okay. Let's make sure we understand that. Okay, just like mass, volume or density, it is measurable. Yeah, measurable, yeah, it's like saying I can measure color by, maybe in the case of red, you can have 610 nanometer wavelength. Okay, so you measured it, 610 nanometers. Great, and we measure, so, but he said it's the flow of charged particles. And other people just say it's flow of charges. Okay. A charged battery has higher mass than it does discharge when placed on scales. So why does it weigh differently? That's what you got to explain. So to say that a charged battery weighs more, what are you saying? Its soul, its spirit weighs something, when you can pull that spirit out and say, here's the charge, here's the spirit. See, these people go back and forth between treating charge as a mathematical concept and as a standalone physical object. And they get confused. They equate them duality, right? And they get away with it and they don't even realize it. Now, they're not smart enough to figure this stuff out. Okay, so let's kill that parrot there who all they do is just parrot the official words out there, whatever they learn at the monastery. Let's kill the parrot. Okay, if a battery weighs more when it is charged, does that make charge a physical object? If charge is a property of matter like color or size, does that make charge a physical object? If electrical energy results from the flow of charged so-called particles, does that make charge a physical object? And if energy is the capacity and a battery stores this capacity, right, is energy a physical object? I mean, what are you storing? I mean, it's not like storing beer in your fridge, right? Can you see or touch capacity? And if you can't see or touch capacity, hopefully you don't define an object as that which you can see or touch, because then you would not be able to touch energy or call it a physical object, right? Which is the way he treated it here. Okay, so Yeah, all these people, all they do is just parrot. They just copy and paste stuff. They don't even analyze the stuff that they copy and paste. They just say, this is what I learned at the monastery. This is the catechism I had to memorize. Okay. Counting beads on the rosary. Poor people. They should try to get their money back from wherever they studied, because they gypped them. They gave them a piece of paper, worthless piece of paper. They said, you're a PhD. Oh, yeah, so great. But he got one right. He says, fields are mathematical representation of interactions. Absolutely, it's a mathematical representation. That's all that a field is, okay? And here we look it up just in case, okay, to make sure that everybody understands this, okay? What is a field? A quantity, okay? This comes out of the Wikipedia, all of this. Represented by a number that has a value for each point in space and time. Okay, so what is a number? Well, a number is a mathematical object, they say, okay, used to count, measure, and label. Okay, great. What is a value? Well, value is any definite mathematical object, again, all these mathematical objects, right? Most often a number. Point, an exact location in the space, and has no length, width, or height. So yeah, hopefully a location has no length, width, or height, right? Space and time, what is space and time? Any mathematical model which fuses the 3 dimensions of space and the 1 dimension of time, okay? And then just in case we look at space and time separately, space is the fundamental space. I like that definition, etc., okay? I stopped there because there wasn't any point continuing if space is the fundamental space, right? And time, what is time? The continued sequence of existence and events that occurs in irreversible succession from the past through the present into the future. So you wonder how they can bend time or warp time if this is the definition of time. Okay? What are you warping? You're warping what? Continued sequence of existence? Is that what you're warping? Okay, and so you see what a field is down at the bottom, which is what this fellow said. It's just a representation, mathematical representation. That's all it is, a bunch of numbers. The only condition that you have to keep in mind is that numbers get smaller the farther away they are from ground zero. So if you have gravity, right, it gets weaker the farther away you get from like the center of the earth or from whatever object you're talking about. If you're talking about magnetism, same thing, it gets weaker the farther away you get, okay? So a field is what? A bunch of numbers, values in space. What do you mean by space? It means that all these numbers are floating in space. Of course, you're not supposed to imagine it like that because it's a mathematical concept, nothing but. That's what a field is. And a lot of these people don't understand that. The word field was created by Mr. Faraday in the 1830s, and he called a field like magnetic field because he said, there's these lines there that have an effect on visible matter. He couldn't see the field, right? And so he said, well, I'm going to call this a magnetic field. And so people now say, oh, a magnetic field, what is that? Well, if you put a little charge in that field region, right, the field has different strengths at different locations. And so the field became a series of numbers that describe each location that comprises the so-called field. Okay, and that's what a field is. There is no physical standalone object called field. The so-called field is under the rope model is very simple. It's the threads that are sweeping around in that region. Now you have a physical object, they're threads, and you can't see or touch them. Okay? But we're not talking about values. Mathematics just talks about the value that a charge would have. In other words, what acceleration, what force, etc., what energy you impart on a charged particle that is found within the field. That's how the field is interpreted. In other words, it's a mathematical concept. And it's a mathematical concept made of many mathematical numbers, which is just a value for each point in space. And you can't turn that into an object and say, oh, the field is a physical object. No, the object are the threads that are sweeping around that form this so-called field, the region where a particle is influenced. Okay, so physics is about objects, not about math, about numbers. Okay, continuing here. Any thoughts on why an electrical circuit has to be closed? And when this guy asked this question, I had no choice but to answer it, and that was the subject matter of today. So this is the question we're going to try to answer, okay? Why do we have to close that circuit? Okay? Why can't we leave it open and have, all the electricity fly through the air? Very important question because, according to quantum mechanics, electricity, they got rid of the atom. They don't even need the atom anymore. Now it's just a flow of electrons. So all the electron beads, like, bullets, flow through space, and that's called electricity. So there should be no reason for the electrons to jump the gap there and reach the other side. Okay? Why not? Why don't they? Why don't they just jump across in space, especially? You have this circuit in space, there's nothing there. Well, not in quantum, even the false vacuum is made of stuff, right? But I mean, in rational science, you got empty space there. We don't need to put the word empty because space is that which doesn't have shape. And so the question is, will the electrons jump across from one point to the other across that gap? Okay, and if not, why do we have to close it? Why do we have to close the circuit, make a closed circuit, closed loop circuit? Okay, very important question, right? Because this is the one that leads us to an understanding of electricity. Okay, here we have a DC circuit, and we talked about that the other day, which is what this fellow is saying. You know, if you close the circuit, you have all these electrons flowing, direct current, right? AC, alternating current, a little different, looks more like this. Showed this the other day, and it just goes back and forth because you're changing the polarities constantly, okay, somehow. And so the question is, you know, which one is electricity? Does electricity have to go all around, or does electricity just move back and forth? Okay, but the point here is that in AC, at least, right, it's a local phenomenon. If you put a lamp there where that resistor is on the right side there, well, then it's going to turn on. Okay, so the question is, how do those electrons produce this light? Why does the light turn on when those electrons are moving back and forth between atoms? Okay. Okay, so let's move on here. This is what it looks like in a vacuum chamber. Okay, important to see this as well. Okay, and there you see the atoms, and essentially this is the notion they have. Electron beads just moving from atom to atom, from one plate to another, from cathode to anode. Okay, okay, so this is their notion. We compared it against the one that we propose instead, which is this. We're saying that actually electricity is the bunch of merged electron shells that are spinning in situ. Okay. Okay, and so now we get to voltage and find out why that had to be connected. Okay, and we start with a definition of voltage. First, we need to know what this voltage is, because it's voltage that triggers whether you use my version, which is the merged electron shells that are spinning in situ, or you use the bead model where the electron bead goes from atom to atom. You need to have this thingy trigger it, which is known as voltage. And what the hell is voltage? Okay, and it's got something to do with positive and negative. Okay, and here you have definition. It says voltage, potential difference or electric pressure, is the difference in electric potential between 2 points. Okay, so it's some kind of pressures, some potential difference, whatever that is. Right now we don't know, but this is the definition. Okay, so we have 2 points, and there's a difference in potential, or there's pressure from one point to the other. Okay, pressure we all understand, right? You push the box, that's called pressure. Pressure is push. Okay. On the other hand, potential difference, well, usually it's the notion that we have of gravity. Like if you're on a mountain and you jump, hopefully with a parachute or something, right? You fall downwards. Okay. Why? Because there's a potential difference. They call that a potential. Why? We don't know, because again, with the word potential, we're not identifying the invisible object that's pulling on you or pushing on you. All we're doing is saying there is a potential difference. That's just mathematics, and that's just a description. Okay, so let's distinguish that from explanation, which is what caused you to fall downwards. Why did you fall to the sky? Okay, that's the issue that we're trying to resolve here. It says voltage is defined so that negatively charged objects are pulled towards higher voltages, while positively charged objects are pulled towards lower voltages. So we have this potential difference, okay? And so they're just introducing this notion of positive and negative. And you say, well, what does that mean in physical terms? What is this positive and negative? And it turns out that they never defined it. They have no idea what positive and negative is. They could have said it's A and Z, just like they say north and south, right? They could have said east and west. I mean, what is this positive and negative? What does it mean from a physical standpoint, okay? And, you know, we always say, well, the positive side of the magnet attracts the negative side. Yeah, you could say A attracts B, red attracts blue. You could have said many things. What's the difference between positive and negative? Okay, that's what we need to figure out. Otherwise, you know, all you did was just a description. You still don't understand how a magnet works. Okay, and so here we have the notion that they have of voltage, okay? And it's this notion of water. They say this is a difference in potential. So they have the positive on the top, negative on the bottom. It could be the other way around, depending on what particle is it the positive particle that's moving towards the other side? Okay, so keep that in mind. They have no idea, so this is arbitrary that you can put a positive on the high one and the negative on the low one. It could be the other way around. Okay, in fact, the next thing shows it here. Okay, is that what we're saying? We're saying that we have something that is higher than the other. Is that why the electron beads roll downwards to the one on the bottom? Is that the analogy? Let me show that again, okay, side by side. I mean, what they're saying, and again, don't worry about the signs, because again, they say that the positive could go to the negative or vice versa. So the signs are really unimportant in that sense in what I'm showing here. The important here is that they're saying it's a difference in potential. That's what I'm showing here. So a difference in potential, we can all understand the analogy of the water flowing downwards because it's gravity, whatever gravity is. Okay, we're not concerned about that right now. We're just saying there's a difference in potential because of gravity, because water tends to go down. So they use this as an analogy for voltage. Are we saying that the electron beads, which is what is rolling in this case, right, which is what's going from one atom to another, are we saying that the electron beads are flowing downwards because one of the terminals is higher than the other? Can we switch them around and find out if the electron beads flow in the other direction? Can we lift the positive, in this case, in this example, higher than the negative, and now the electron beads will flow in the other direction? Because if this is not the case, then the analogy, the water analogy, is irrelevant. It has nothing to do with what electricity is. So the analogy is wrong. But this is the analogy 99% of the people out there use to explain voltage. They say it's just a difference in potential. Well, what do you mean a difference in potential? We understand the water one. How does that work with electricity? Are the electron beads rolling down an inclined plane? That's the question. Okay, let's get rid of these. Okay, so you see where I'm going with all this. If this is voltage and it's a difference in potential, are the beads rolling downwards on an inclined plane? Well, very easy. We could just put one terminal in the higher than the other, and will the electron beads flow in the opposite direction? Well, I don't think so. Okay, so the analogy is worthless because we haven't understood anything. All we understood is that the word potential, and potential is a mathematical term. It has nothing to do with physics. Okay, so potential, no go. Okay, so here's the quantum mechanics version of a battery, a lead battery. I'm going to go with the simplest of all. I'm not going to cover all the possibilities, the hundreds of possibilities that there are for generating current and voltage and so on. I'm going to look at this, which is the lead battery, lead acid battery, which is the first battery that was invented, I think. And so the issue here is why do those beads, the electron beads, go around? You can see the red ones there. Those are supposedly the electron beads are going around in the circuit. Okay, what causes them to go around? Okay, and for that you need to look at the chemistry of this. Okay, so let's move to the chemistry. Here you have it. Okay, you have the electron beads flowing, but what's happening? What's triggering that? Well, you have the one side, one battery is lead, and the other one is lead dioxide. Okay, and what happens, there's a chemical reaction with the sulfuric acid, that's diluted sulfuric acid, okay? That's that bath there. And there you have the chemical reactions, okay? And you create these hydrogen ions, okay? And what happens is that they say when those chemical reactions take place, the beads move around. The electron beads move around from one terminal to the other. Okay, so you need that chemical reaction, and you can see that it's a closed system. The question is whether that reaction would stay in place, would remain, if you break that circuit. Okay, and the issue here is that you have to be aware of is the following, that there's a reaction between the sulfuric acid there and the lead, okay, but there's a chemical reaction that you can have if you just pour sulfuric acid on lead. There will be a certain reaction there, but that doesn't cause electricity per se. In order for you to have electricity, you need to connect that wire, okay, around the green wire, all around, and there has to be a closed system because now the electron beads flow and they stimulate the reaction between the sulfuric acid and the lead terminals. Okay, so that's what you have to keep in mind. Okay, the reaction is stimulated by the electricity. Otherwise, you would not have that flow of in other words, it speeds up the reaction. That's the point. Otherwise, you would have just a chemical reaction between the acid and one lead terminal, which is a very slow process. Okay, the electricity is what speeds it all up. Okay, and so one thing you have to keep in mind is that that is really a what you're seeing there, the electron beams moving straight forward. That's not really how it's done, but that's how it's always illustrated. Let's illustrate it a little more like it is, okay? And here it is. They jiggle around, they kind of spiral around. The electron beads are known to spiral around the wire as they move. So this notion here that you see here, this one is wrong. Okay, it's not straightforward from atom to atom. For some reason, okay, for some reason, they do this. They move around like oscillating. They spiral around the wire. Okay, and this is very important to understand that. Okay, and it's already been shown through many observations, many experiments in the past that this is the case, that these things go around. It's like a fact. So we don't need to, I mean, if you have doubts about it, go to a lab and do your experiment, convince yourself of it. This is something that is already well known. It's a fact. It's like saying that the earth is round and you're saying, no, the earth is flat. Yeah, if you want to buck the trend and say it's flat, fine, you're a flat earther, great. No, the earth is round and spherical, okay? And that's why gravity works. Otherwise, gravity wouldn't work. And likewise, the fact that the electrons spiral around has already been shown ad nauseum. And here you see, it's known as Fleming's rule, really, but here you see AC going back and forth, okay? And the question is, this AC, it doesn't flow all the way. It's like it's not only spiraling, okay, so these two things have to be put together. Not only are the electrons spiraling, but they're not moving all the way to the terminal. They're what was his name? Derek Muller suggested, and which is shown by the AC, that the electron doesn't move very much. It drifts very little. They said it's the field that moves at the speed of light. It's the signal that moves. But the electron moves very little, they say. Okay? So let's see. The electron moves very little and it's spiraling. So more or less it's spiraling in situ. And you have tons of these electrons spiraling in situ. Okay? So keep that in mind. This is what we're seeing here. And again, this comes from what is known as Fleming's rule. Okay, here you see it. This fellow, his name was John Fleming. Okay, he was an electrician. He worked for Marconi, beginning of the 20th century. And he came up with the left-hand rule, which is what you see there. Force goes perpendicular to magnetic field, which is perpendicular to current. All three are perpendicular to each other. And there you see it with the light, the electromagnetic wave. Okay, you have the electric field one direction, magnetic field 90 degrees to it. Okay, and where's the force, or where's the energy? Which direction is light traveling? Perpendicular to both. Okay, we got that? Okay, so here we have Fleming's rule applied to electrons, and you can see they're spiraling around. If you find an electron in a magnetic field, okay, what you'll see is that it'll spiral around, okay, because it's moving in one direction while it's going in circles. And so what that does is compel just think of that trajectory, okay? It's not only going around, but going around forward, which is a spiral path. In fact, that's what the people at the Large Hadron Collider say. They accelerate electrons, they accelerate protons. They don't say that the electron moves back and forth. They say, no, we accelerate all around the beamline. What do you mean? I thought that was just moving a little bit, and what you're accelerating is what? The field, the signal, the abstract numbers. And these people say, no, we accelerate the electron beads. Or the ions, they allegedly strip the electron from a hydrogen atom, they're accelerating the protons. They don't say that the proton moves back and forth. They say they accelerate it all around the beamline. Okay, and here you have the helix. Okay, another version of that same one. It's a helix going inside a wire. Okay, that's what it is. It's a helical motion. It's a spiraling type of motion. Okay, so that's how an electron moves along a wire. Okay, but then again, does it move all the way, or does it move just a little bit? Okay, how does it move? Does it move a little bit, or does it move? In other words, does it move in situ essentially and in circles? Meaning, if it moved a little bit forward in circle, it described a helix, a spiral, right? Keep that in mind. That's the motion. So, what are these people showing? Well, they're showing something like this. They're saying in a magnetic field, the force is always at right angles to the motion of the electron, Fleming's left-hand rule. And so the resulting path of the electron is circular. And if it's moving forward, it's a spiral. Okay. What are all these people describing? Well, it seems like they're describing a rope turning in place, or what I call the serpentine, merged cells, right? That's what it would appear. Okay, let's find out. Here we have the dynamic version of that, okay, just so you can see it. Okay, so in a magnetic field, the electron would behave like that. It's kind of spiraling. And if the electron is moving in some direction, right? For example, in the direction of the arrows there, well then, yeah, it's gonna move like a spiral. It's gonna be a spiraling motion. Okay. Okay, so what are these people describing? What can we conclude from this? Here it is. These are the conclusions. Let me get that. How did that become so big? Give me a second here. Okay, let's get it up here. Okay, so what have these folks been describing all these years? Well, the electron bead spirals. Okay, it spirals more or less in situ. Okay, it doesn't move very far. They say the electron beam moves very little, like from one atom to the next, in a spiraling manner, right? Because it's got to return if it's going to do alternate current. It doesn't go all the way. What travels all the way, what travels at the speed of light, is the field, the signal. Okay, we covered that the other day. It doesn't travel all the way to the terminal, and it spirals for no reason. They have no mechanism for why that electron bead spirals or even moves outside the atom to begin with, except this so-called voltage thingy, which we still don't know what it is. It's just a potential difference, between something high and something low, some kind of pressure of what, of who knows what, because we don't have the what. It just says it's pressure, whatever that is, right? Whatever's causing it. It is surrounded by lines of force, okay? Remember, when the electron moves, it moves in a magnetic field. What is a field? A bunch of lines of force. That's what a field is, a magnetic field, right? Okay, known collectively as a magnetic field. What is the rope model? Merged electron shells swinging threads around. Okay, so we have all these merged shells. Okay, their electrons are made of the same threads as the rope that interconnects them. We have two atoms. Okay, to make it simple, two atoms which are merged one with the other, like I showed the other day in the case of hydrogen gas, H2. It's just two atoms, two merged atoms, a figure 8 atom molecule. And all these are turning around. When they do, they swing around the threads. Okay, some of the threads that either that make up the rope between them or the ones that make up their own bodies. Some of those threads start swinging around. Okay, and so what is this positive, negative? It's clockwise, counterclockwise rotation. From one point of view, you see it as clockwise. And if I do this, well, for you, hopefully this is counterclockwise, right? For me, it's from my vantage point, right? Okay, I'm seeing that my hand is moving clockwise, but from your point of view, hopefully it's going counterclockwise. Okay, and that's what's happening. It's just clockwise, counterclockwise rotation of the whole serpentine, as I call it, extensive rows of electron shells, merged electron shells. And so a circuit must be closed for the entire serpentine to twirl on itself and stimulate the chemical reaction between the sulfuric acid and either the lead or the lead dioxide. Turns it into lead, sulfate. So the issue here is the following, that you need that chemical reaction because if you just pour acid, sulfuric acid, you pour it on lead, there's going to be a chemical reaction there. It's a slow, it's like almost if you pour water on iron. Will there be a reaction? Well, yeah, you can have oxidation over time, rust, right? It takes a long time. But if you stimulate it with electricity, that reaction is much faster. And that's what's happening. What you have is the serpentine is twirling all around the circuit. By doing so, it comes back to the other terminal, and now what it's doing is stimulating the reaction. Now the reaction is faster, which stimulates the twirling of the entire serpentine that goes around. And so by going around and twirling fast, it's a self-sustaining system. Okay, until you open the circuit. Okay, so that's the notion we want to give you there. Okay, and here is, we're going to illustrate that. Okay, here's the reaction. Here's the bath, and you have the sulfuric in contact with the lead and the lead dioxide, and it's relatively slow. That's what I'm trying to illustrate there. It's a relatively slow process, okay? But what happens when you put the circuit in there, when you connect the terminals? Well, now what you have is, it moves a lot faster, okay? Moves faster, and what it does is trigger the reaction to occur faster, and that's why we have electricity. Now the serpentine that goes, or serpentines, there's many of them, going around, they move a lot faster. Electricity does stimulate the reaction, which in turn stimulates the electricity moving around, okay? And again, I'm doing this with the lead battery, okay? I want to make sure that you understand that this is just for the lead battery. There are other scenarios, and people are going to say, Bill, you didn't explain this, you didn't explain that. Yeah, right now I just want people to understand the basics, how it how it works with the lead battery, okay? Very simple. You have a reaction between sulfuric and the metal, and if you just have that reaction and nothing else, no, you've got you got a very slow process, and there is no electricity there. If you want electricity, you got to connect the terminal to the other side, right, through a wire, and that whole thing is now connected, around the wire, and the serpentine now is what triggers the whole reaction to occur. Okay, so you need a closed circuit because of that.